Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, solve the next question, number 8 of Neet Physics paper 2015. Students, let us solve the question number 8. Two identical thin plano-convex glass lenses, refractive index 1.5, each having radius of curvature 20 cm, are located with their convex surfaces in contact at the center. The intervening space is filled with oil of refractive index 1.7. The focal length of the combination is. Now the question is that we have got two plano-convex lenses like this. This is one, and the other one is also like that. Their convex surfaces in contact. So that means these surfaces are in contact. And the intervening medium is filled with liquid. This is filled with liquid of refractive index 1.7. This is suppose this is having refractive index of 1.5. Outside it is air, so refractive index is 1. Here also it is 1. This is for air, refractive index 1. This is for glass. This is for the liquid that is kept in between. If I see properly, you can see that this portion behaves like a concave lens. This portion behaves like a concave lens. So basically it is a combination of three lenses: plano-convex, a concave lens, and again a plano-convex lens. So what we are supposed to find is the focal length of the combination. This consists of three lenses, as I have discussed. So I will find the focal length of the combination, and that can be obtained by the 1 upon f1 plus 1 upon f2 plus 1 upon f3. The focal length of this I consider as f1. This one is having focal length of f2, and this one is having focal length of f3. In fact, f1 and f2 are identical, so they have same focal length. So I can write that these two being same, I can write 2 divided by focal length of the lenses plus 1 divided by focal length of the concave lens. So this is the formula we have reached, and we have to find these values, put these values and solve it to get the answer. Now to do so, we have to find the focal length by lens maker's formula. So the lens maker's formula what is that lens maker's formula? It is used to find the focal length of lens. It says that the focal length of the lens 1 upon f, focal length of the lens, it might be any type of lens, is given by mu minus 1 into 1 upon r1 minus 1 upon r2. This is the formula, where this mu is the refractive index of the lens with respect to the medium in which it is kept. This is the refractive index of the medium with respect to of the lens with respect to medium. So and r1 r2 are the corresponding radii of curvature. If I use this formula for the first lens, my plano-convex, because the two planar convex lenses, if I use for the first one or the last one, it all are the same. It is having a focal length I have considered f1, and that f1 is 20 centimeter. Sorry, the radius curvature is 20 centimeter. Okay, each having radius of curvature 20 centimeter. So what is the, if this is R1 and this is R2, R2 is 20 and R1 is infinite, because this is plane, radius of curvature is infinite. And this is negative because it is lying, this radius of curvature will lie to the left of this. So I can write that 1 upon f1 is mu minus 1. Here this is the refractive index of the lens, which is 1.5 minus 1 because it is kept in air, into 1 over r1, which is infinity, minus 1 over r2, which is minus 20. While using this formula, we have to note that you have to put the sign, with sign you have to put the values of r1 and r2. So if I solve this, this comes out to be, this is 0.5, this is half, and this is 1 by 20, this plus, and this is 1 over 40. So 1 upon f1 is 1 upon 40, so therefore 2 upon f1 is 2 over 40. Whatever is that, that is equation 1, say. Because we are interested in putting the value here, 2 upon f1, I already got 2 upon f1 is 2 over 40. Now I am looking for 1 upon f2 that I've got to find. Second, focal length of second lens, that is the concave lens. So this is and the liquid is 1.7 refractive index, and for this we have to calculate the focal length. So 1 over f2 equals to mu of the liquid minus 1 into 1 over r1 minus 1 over r2. Now mu L is given as 1.7 minus 1 into 1 over r1. And what is r1? This is our r1. This is your r1 measured from here, and it is measured towards the left, so it is negative. So it is negative 1 over r1, which is 20, minus 1 over r2. R2 is lying this side, and it's positive. This is negative, so this is 20. If I calculate that, this is 0.7, and this is minus 2 over 20. That is minus 1 by 10, and this is minus 1 by 100, 700. So minus 7 by 100. This is your 1 by f2. This is equation number 2. Now after you have this equation 1 and 2, I will just substitute the values of 1 and 2 in the original formula, that is 1 of the f combo is 2 upon f1 plus 2 upon 1 upon f2. So 1 upon focal length of the combination is 2 upon f1 plus 1 over f2. 2 over f1 we have already got, that is 2 divided by 40, and this one we are getting minus 7 divided by 100. So we have to solve this. We can take 1 over 10, or I can multiply 10 here and 10 here, so that this is 40 and this is 6. Okay, I'll take 1 by 10 common. So it's 2 over 4 minus 7 over 10. This is half minus 7 over 10. So this is 5 minus 7. So it is 1 by 10. and this is 10 minus 14. Okay, this is or if I can multiply 5 here, 5 here, this is 5 minus 7, this is 5 minus 7, okay, divided by 10. Okay, so I multiply 5 here, 5 here, so it becomes 10, 10 is common, 5 minus 7. So from here I'll get 1 over 100 into minus 2, that is minus 2 over 100. So 1 upon f combo is this, so which is equal to minus 1 over 50. Therefore f focal length of the combination is equal to minus of 50 centimeters. If I see the options, then minus 50, the option number 1 is the correct answer to this question. Okay, thank you.